Um, Done? All right. Okay. Right. Hi, everyone. Yes, I'm Alex from StartHQ, and today I'm going to talk about like this server-side, stuff that we use on our project. And let's get started. Right. So first thing we use Node on Node.js on as our backend, and one thing that we're not very comfortable with is the whole asynchronous callback programming style that the API provides. So it's one of those things where I'm coming from like Java background and all that, and sequential programming is like be easier. So Fibers is one of these framework that is quite easy to use. It basically supports this concept of threading inside the Node file framework. Uh, well, bear in mind that this is more like a Windows 3.1 sort of cooperative multitasking, which means that if one of your many threads is holding the whole process, then no one else can actually get to run. So it's more like an event loop thing. Um, it's got these individual stacks to store the variable and stuff. So it's actually remember, it's just like a plug-in that patch V8 to actually achieve this sort of like yield and resume sort of functionality. So well, it's similar to the generators and stuff, but in the sense that, but then in the sense it's easier to use because it's mostly just like JavaScript as you know it, so there's no like special keywords and stuff like that. Well, here's an example of how it's being used, and this is the classical sleep function, whereby you call sleep, and at the next line will return to, and then this is how you use it, and with the asynchronous programming style, we'll be calling set timeout to actually inject the function you want to run next into, as a separate function. Whereas with Fibers, you can just, do a sequential style. So, like the third line would be, delayed by 1 second. So it makes life a bit easier in the sense that, for example, if I'm trying to say catch a exception and stuff like that here, like in that, try out in the first example, trying to do a try catch around this is not going to help if the exception happens inside this function here. Whereas in the second case, it will just catch anything. Right. So so there's a thing called common.js, which is I'll just briefly talk about. It's just a set of specifications, and it defines module packages and even testing if anyone does anything like that. Right. So and also on top of that, it does something useful stuff like the binary. So rather than JavaScript only have like strings and numbers in it, which is not very helpful. So it's binary, I/O, file systems, and even like the more like the request response sort of JSGI stuff. And I think the earliest example of implementation is via Ringo.js. So it uses the Rhino, I think it's JS192, JSR192. So it uses the Rhino runtime on top of the JVM, JavaScript, the Java virtual machine, and Ringo.js is it's basically implements most things common.js on top of it. Now the Node came out, and it has the same packages, modules, and all that. But because it kind of promotes asynchronous styles of programming, especially with I/O and stuff, so it doesn't actually implement most of common.js, like the I/O and stuff. So Common Node, which is something that actually Oleg's written, or at least he started it. It's so basically we implement the common.js spec on top of Node. So you can literally whatever code that used to run on Ringo.js, you can almost just move it over to run on top of Node using common Node. And as I was illustrated earlier with the Fibers as well, it makes programming easier. As in, at least personally, I found that being able to sequential code stuff and to be able to like put all the I/O logic in like one sequential function is a bit easier than having to create all those anomalous function, pass it all in, and then have unhandled events exception thrown at you, not knowing where the actual error happens. Also, well, being an abstraction on top, or library on top of Node, we actually managed to achieve, minimal performance loss, and in one of the cases, actually faster than the existing node when it comes to streams. So uses slightly more memory, actually mostly due to the use of fibers. And here's a quick graph showing that. I mean, there's some tests and all that. Actually, all these tests are all there in all these benchmarks are all in the Common Node GitHub project. So you guys can go and run it yourself. Um, yeah. Oh, right. Yeah, I should probably explain that, shouldn't I? Right. So with the IO implementation we have, so in the upgrade from Nook Stream to Stream 2, I tried to fix that to actually make it work with Stream 2, and we decided to go with this design where it's a copy on write. So we actually only create a new stream, or sorry, with the binary stuff. Sorry, with the binary, so we only create a new binary object on when you actually modify stuff. So we actually cut down on the pressure on the garbage collector on Node, which actually gives us less GC time, which is why we're actually able to achieve higher performance than if you use buffer on Node directly. So anyway, there's that minor details. Right. So here's we decided to show some examples on like things. So with the old style streams on Node, which I think you can still use it with 0.10.15. Yeah, to trigger that. Right.
Yeah, I was saying that currently Node supports both style of APIs, so streams and streams too. And like I guess the slides will show that, but you can actually have a stream turn into an old style stream module by calling .resume on it. But that's going to be deprecated in the next kind of major release.
Mhm. Right. So well, that's the so this is the old style to some people will recognize it, or people who use Node will recognize it. And it just data event comes in, collect the chunks, and do something about the actual data you've collected. Streams 2, similar, is now readable, so you actually have to go and read it yourself. Right, with Common Node, so this is the streams Common JS streams. You can use this style up there where you just just read. As you can see, there's no anomalous functions. Literally everything is like from top to bottom is like the same function. Or actually, you can just use one of the methods provided, which is to read the entire stream. Now, it will block on the I/O, but then the other fibers threads will then continue to run. So it actually doesn't block your whole program. So it's all these managements of multiple threads running, serving all the requests and all this all taken care of for you. And right. So so this whole there's so since then there's a lot of other modules on top of the common node system. So all the Ringo modules you can use because we re-implemented the common JS specification to actually support all of that. There's common utils which got things like MD5 and stuff like that that's useful. Mongo Sync is basically the synchronous API version for talking to the MongoDB. So it is just the normal. In fact, it's imitated quite closely to the command line on Mongo. So the Mongo command line tool, the syntax in there is quite similar to that in when you use Mongo Sync. So actually, time and time now, just look up on MongoDB documentation to actually work out how to actually call some of the stuff here. Right. So on the website front, we got Stick. So it's kind of pretty standard stuff to use. And also, you can actually use because of Fiber, you can actually wrap existing Node modules so that you can actually convert some of these API calls uses got asynchronous callbacks on it, you can actually just inject like fibers yield and resume in it to actually make it synchronous again. In fact, some of the function calls inside the file system implementation on common node is actually just using that trick. So they actually use almost using the FS module of Node directly, apart from just the fact that just the callback is now a flag to actually there to wait for the next line of function to resume. That's all it is. Right. Yes, our whole code base on the server side is based on common node on StartHQ, and we even we have background processors and stuff, so the extractors, for example, which so we on StartHQ, if anyone have visited our website, we basically have a web app directory where we show like different web apps, on the catalog. And the one thing that we do do on them is to say extracts all the latest blog posts, news items about them, price plans, and all the other metrics. And extractors are basically individual bots that will actually go and collect every single one of these pieces of information. Now, so they all run autonomously in the background, so to speak, and also have like dependency on each other and whatnot. So one example is there is an extractor that will go to Bing. Yes, we use we don't use Google search engine for some reason. So ouch. But so we use that to try to look for things like the what was it, the potential like blog URL and all that, because like some sites has blog.something.com and that's their blog site, but many others don't. So they was trying to extract something like that, and then another extractor based on that information will actually go and visit the site to try and extract the RSS or the atom feed for the blog post. And you actually have like can actually build quite complex dependency layer, and we're talking about like 1,000 apps crawling through them every day just to get the latest blog post. So when you visit the web app directory, that's actually what you're getting. It's all automatic. There's no like monkey in the background trying to crawl through 1,000 apps per day. So yes, there is that bit. Yes, when something goes wrong, yes. But on most days, yes, and also right. We also have like, because of the synchronous programming style, and I was saying, one of its prime example being that you can try cache the whole lot. You actually get very nice stack traces. So rather than keep getting this unhandled event stack trace, which probably, I don't know, my people who use Node probably keep seeing them, and you can actually capture a meaningful stack trace throughout your source code. Actually, then you can upload a sentry or whatever, and then start reviewing them, and then actually find out where problems are. And time I find it a lot easier, because it's one thing where you can inject information into your various asynchronous callback to then catch there and then report, but there's a lot of work up front. Whereas with this, it's free. I mean, you got the, because it's always running like from line 1 to line 10 with no like event loop calling and all that. You can actually get the full stack trace in meaningful places. So we have, all right. Okay. Yeah, if I find my mouse. Yeah, about that. Ooh, right. Do you remember the login? Yeah, I do. Yes, so this is one example where you can see, yeah, there's no source code in there, but you can see clearly the stack traces, and actually when you in our case reports all the um, node modules and the version of it. So there are some bugs where it only happens in one version, not the other, and we keep running into those as well. So right, yep. Right, so let's talk about some of the less nice things about these things. And right, fibers is, and the reason why we didn't just use fibers on its own, well, partly because of the CommonJS stuff. So Common Node implements CommonJS, so it's easier to port your code over and stuff like that. But with fiber, you have to, yes, you notice from like the example at the beginning, you have to like wrap a whole function inside the core to fiber in order to actually use any of them. And one of the kind of annoying thing is that if you don't do that, like if you don't use common node, which already wraps everything that you then run as a JavaScript code inside a fiber, then you always end up a situation where you'll be accessing the fiber states outside of the fiber core, and that never ends well. So one of the major problems is, for example, when people use Express, which has lots of async callback in the API. So they get all these weird errors. It's simply because, of course, the asynchronous function callback is being shoved in the event loop, which is not wrapped, around by fiber. So there's that. Another one which is kind of annoying as well, which is the writing to global variables. So it's kind of like concurrency in general. Like your multi-threaded programming, global variables bad, or static variables they call it, is a bad thing. But in the case of fibers or node in general, it's even worse because it will crash kind of unexpectedly. It doesn't crash straight away. So it's like after a while, it will crash with some weird errors in weird places. So I think it's looks most likely to be a memory corruption issue. So it's kind of hard to, so make sure that like you do not have any global variables that, especially when you misspell something you didn't notice, that sort of thing. And it's kind of nasty. Right. So this is, another thing is this is more to do with NPM really, which is that if your project depends on modules or some other modules, but they also depend on fibers, it will install fiber twice, and then it will use you know, so you are using like your direct dependency, that copy of fiber, but then your module will actually use the one that they depend on, and it's kind of annoying. It's a known bug on fiber as well, but then like on the project website as well. But it's one of those things that's how NPM behaves. So it's kind of, I mean, there's a good example where we run into in Mongo Sync, because Mongo Sync depends on FiberOffice to make it, to have the ability to synchronously, present synchronous API for talking to Mongo. And so we have to work around that by, trying to detect whether, like you also have like a global copy of fibers installed and trying to use that instead. Right. And well, lastly, so this problem with that, actually, this is more like also a problem with Node as well, which is the fact that if something, so if one of the many spawned fibers crashes and you didn't actually catch the exception, you end up with this, unhandled exception thing. And obviously there is this event called uncaught exception. But then, even in the Node documentation, it say, do not use this because. And actually, it's true that if you catch it enough of time, for some reason, the whole node just crash. And they did say that don't use this for actually recovering from an error. So what we ended up doing in our case is to use something called supervisor. It's another NPM module, which basically is kind of funny. So basically, it's just a watchdog. If your main server instance crashes, it respawns it. And when we had this problem with like one of the global variables, which we didn't actually notice was happening because we spelled one of the variables, doing it like every like 10 minutes or something like that. And we didn't spot it because Supervisor was doing such a good job responding the server. It never was a problem until we look at the stack traces, like what the, so in the log file it's like a lot of like stack traces of unhandled event, and we realized, okay, maybe we should do something about that. So yes. All right. Mm-hmm. Mm-hmm. Yeah, and that the whole point is that like it's not like just your code being buggy and it crash your whole server. It's the fact that any of the dependency module you've got throws an exception which is not being caught. Yeah, that also that just crashed the whole node instance right there. So yeah, just be careful. Right. So these are the GitHub links to various projects. I mean, Fibers. Oleg has written, well, common node, but Oleg has also written like an example, like a project called Nodes, and you can actually use that to actually learn how to use common node and like take, yeah. Hmm. And StartHQ has also exposed its extractor API. The cool thing I talk about, that the bots that go around and crawl around stuff. You can actually check it out and even contribute cool and new extractors to us if you want. That's about it. Yeah, thanks.
Yeah, for the problem with having two instances or more of the fibers, I think there's a node command, I think it's called flatten, which yeah, so which basically detects dependencies that can be used as the same library. So does that work for your case?
Well, have you actually tried it? I mean, I haven't actually.
I've played around with it, but I don't trust it.
Yeah.
So our solution is a kind of a
Yeah.
So the solution is because Common Node is sort of like the base on top of which other things are built. So what we do is we shove a reference to the fiber library, attach it to the global variable. So like global.fiber is the Common Node version of fiber, and then Mongo sync checks if that exists, and if that exists, it uses that, and if it doesn't exist, in other words, if Mongo sync is running outside of Common Node, then it just uses its own reference. So that's the solution. But yeah, npm prune ought to work, but I'm not a huge fan of npm in the sense that I don't think I've looked at the code and I don't think it's the most reliable thing ever. So we've chosen not to rely on that.
Yeah, well, that approach does have the problem that if you have two different versions of fibers, then you're in trouble.
Yeah.
So if they're not compliant.
Behind you.
So I haven't used Fiber before, but my question is related. You're using basically a fixed number of threads, I guess, some sort of thread pool for Fiber. So doesn't this sort of like kill the killer feature of Node of being able to handle 1 bazillion connections at the same time?
Well, actually, we don't. We literally spawned a new Viber as a request come in. This actually is in the common node HTTPS server, HTTP server module. But literally, as requests come in, you spawn new Vibers, and then they die. So.
Okay, so you have no limit on how many you can run.
Nope.
Okay,
and
cool.
So far, nothing seems to have crashed. I mean, we managed to. It's a T1 micro instance on Amazon Web Service, and we have about 300 concurrent users any second. So it's holding so far.